Have you ever wondered, is our universe just a computer program? Could everything we see, from stars to people, be part of a giant cosmic simulation? This idea is not just science fiction anymore, it's called the simulation hypothesis, and it's being discussed by philosophers, physicists, mathematicians, and computer scientists. In today's video, we will explore why this hypothesis exists, how it could work, and what it would take in terms of physics, mathematics, and computing power to run a universe-size simulation. Number one is, what is the simulation hypothesis? The simulation hypothesis suggests that what we think of as reality, the universe, space, time, matter, and even consciousness, might be the output of a computational process running on some kind of supercomputer outside our known universe. Think of it like a super advanced video game. You don't see all the game computations at once. You only see what you interact with. In a similar way, proponents argue our universe might only compute what's necessary for our perspective. This idea first gained wide attention from philosopher Nick Bostrom in 2003, who argued that if future civilizations could run detailed simulations of their ancestors, then most observers like us might be living in a simulated world. Number two is the physics that makes people ask simulation. At first, the simulation hypothesis sounds more like science fiction than real science. But there are features of physics that look surprisingly computational. Mathematical rules everywhere. The law of physics, from Einstein's relativity to quantum mechanics, are expressed in precise mathematical equations. It's as if nature runs on rules and logic, almost like software code. Some physicists have even suggested that information, not matter, is the most fundamental components of reality. If the universe processes information like a computer, this would bridge physics and computation. Planck scale, the universe pixel size. In physics, the Planck length, approximately 1.6 times 10 to the power minus 35 meters. And Planck's time, 5.4 into 10 to the power minus 44 seconds, represent the smallest meaningful units of space and time. These limits suggest that the universe is not continuous but might be quantized, similar to pixel on a screen. This resemblance to discretized digital units made people wonder if the universe might be running on computational ticks like a clock in a simulation. Information limits and the holographic principle. Black hole physics suggests that all the information within a volume of a space can be encoded on its surface area, a concept called the holographic principle. This idea aligned with digital computing because it describes reality in terms of information content rather than physical substance. Number 3 is computing power. Could a supercomputer run a universe? Now here is the big question. How much computing power would it take to simulate an entire universe? Set Lloyd's universe as a computer. Physicists set Lloyd's estimated the computational capacity of our observable universe. According to him, the universe has performed approximately 10 to the power 120 operations on 10 to the power 90 bits of information since the Big Bang. Let's put that in perspective. 10 to the power 120 operations is a 1 followed by 120 zeros. An unimaginable huge number. 10 to the power 90 bits mean the universe contains an immense amount of informational content. If the universe itself is performing this computation naturally, it raises the question, are we inside a computation? Is a simulation possible with finite resources? In computer science, simulating a continuous system requires infinite computing power. Because the universe appears continuous at large scales, simulating every detail would seem impossible. Some theorists argued that if the universe were truly continuous, a computer could never fully replicate it. However, a clever simulation might not need to simulate everything at once, only what's observed. This is similar to how modern video games don't generate the whole world at once, only what the player sees. Rendering on demand, a possible shortcut. One idea borrowed from the computer graphics is rendering on demand. Video games don't calculate every possible event at all times. They focus only on what the player sees. If the universe simulation uses similar tricks, it might only compute detailed physics for what is observed locally. This could drastically reduce required computing power, making a simulation more feasible, at least in theory. Number 4 is quantum computing and artificial intelligence. Quantum computers operate on qubit, which can be both 0 and 1 at the same time. Scientists believe quantum computing could revolutionize processing power in the coming years. In a future civilization, mastered error-free massive quantum computers, they might be capable of simulations beyond anything we can currently imagine. But even with quantum computing, simulating an entire universe in fine detail, including every particle and every quantum event, remains extremely challenging. Artificial intelligence and synthetic intelligence. Advances in AI also blur the lines between computation and cognition. A future AI system can generate fully autonomous virtual minds. That raises deeper questions. How would we know whether our minds are real or simulated. Modern AI systems already write essays and compose music, but they are now here near human consciousness. Still, these developments fuel a speculation about synthetic intelligence and its role in future simulation. Number 5 is challenges and criticism of the simulation hypothesis. The simulation hypothesis is fascinating, but it faces a strong scientific criticism. No experimental proof here. Physicists point out that there is currently no direct experiment or observation providing our universe is a simulation. Even if we saw an anomaly, it could have another explanation. One recent study claimed that the universe cannot be a simulation because some physical aspects cannot be reproduced by any algorithm. This suggests computation alone might be incapable of generating reality as we know it. Other theoretical work argues that the energy and computational resources required to simulate even just the Earth, let alone the entire universe, are astronomically large, may be impossible. Can we ever test it? A major problem with the simulation hypothesis is that if we are in a simulation, the simulator could prevent us from detecting evidence, just like a video game can hide its internal code from the player. In other words, a perfect simulation might be indistinguishable from true reality. Number 6 is scientific and existential implication. Reality and meaning. If the universe is a simulation, what does that mean for reality? Does it make life less meaningful? Or does it just redefine what real means? Some philosophers argue that even if we are simulated, our experiences, joy, love, curiosity, remain subjectively real. The context might change, but the experience feels authentic. Free will and consciousness. If reality is generated by computation, does that mean our choices are predetermined by code? This mixes physics and deep philosophical questions about free will, consciousness, and identity. Are we autonomous beings or complex data points in a vast informational structure? The purpose of a simulation. Why would a higher intelligence run a simulation? Some ideas include scientific curiosity, like how we create simulation to study climate change or galaxy information. Historical reconstruction. A future civilization might simulate ancestors. Entertainment of art. Maybe it's analogous to storytelling or creative exploration. We don't know, but this question pushes us to think deeply about our places in the universe. So number 7, conclusion. The idea that the universe could be a computer program is one of the most fascinating and controversial topics in modern science and philosophy. We look at what simulation hypothesis is, how physics and computation intersect, the sheer computing power that would be required, the role of quantum computing and AI, scientific criticism and limitations, the profound philosophical implication. Whether or not the universe really is a simulation, the discussion pushes the boundaries of human curiosity, science, and imagination. One thing is certain: as computing power, AI, and physics research grow, we will keep exploring questions that blur the lines between reality, information, and existence. If you enjoyed this deep dive into the science behind the simulation hypothesis, give this video a thumbs up, subscribe for more mind-bending content, and let us know in the comments, do you think we might be living in a simulation? Thanks for watching.